Hey, welcome back to another lab overview. So lots to get into, so let's just get into it. So I was able to get through the multi-pass blur for the bonus, and then everything else is completed. Everything's in the lab 6 bonus branch. So if you look in the lab 6 branch, you're just gonna get up to um, the minimum completion. Anyway, jumping right in. So first things first, I've got four different ways of displaying the mixed image. An add, a mix, a screen, and then Pegtop's formula for soft light compositing. So we'll just jump into the Pegtop's formula first. Basically what it's doing is it's creating this hue illusion in the darkest spots of the image, and sort of lighting in the softer parts of the image, and then you're just merging, you're just adding on then the you're just then adding on the whatever's in the background. So that's what you get here. This is the formula for that. So it's in a lot of ways it's similar to a screen, but then it's just adding that fake hue underneath. So then beyond that, we've got the screen. Yeah, the screen. Then just a mix. So it's kind of just overlaying the images with a half alpha, and then just an add, which doesn't look good at all. It just blows. Oh, we're still recording? We're good. Yeah, and then just the add, which just blows out the image. So nothing super useful there. Yeah, but then the mixed color. I think this looks pretty cool. I like this. I like this look. I think it's kind of like, it almost makes it like a night scene, and you got these buildings that have lit storefronts, which I think is pretty cool. So then just to display, you got the basic cube map. So this is buffer A. Nothing special here. This is pretty much the same implementation as the last assignment. So then the bright pass. I've got a linear fall off. I can show that. Wait, that's none of these functions. It's pretty simple. It's not super complicated. It's literally just 0.5x minus 0.5 dx. I don't know why. Anyway, it's just a linear fall off, but it should be intercepting at the 0.5. So you basically get from 0.5 to 0.5. Sort of like, yeah, it's not where it should be. There it goes. It should look something more like closer to that, but something's messed up in here. Anyway, so that's the bright pass. Very simple bright pass. I tried messing around with some other bright pass like functions. I tried some that were like brightness over brightness plus 1, but I mean this one gave me the results that I was more so looking for, so I just sort of stuck with this one. So my bright pass, I calculate the luminance. In the common, luminance is just multiplied by a constant here, and then it's the dot product with the color. So that returns a value of brightness, and then it's just mapped to a grayscale, and that's what we're seeing here. All right, so onto the blur, where a lot of the content is. So as you can see, it working here. So I had a resource that I used for doing pretty much all of the everything, a lot of the optimizations and stuff, as well as how to get exactly what you're looking for in this sort of Gaussian blur. Um, so basically what's going on is I do a lot of the calculations beforehand, before even running the program. So there's all the weights are here, and it's only half of the weights because the weights are symmetrical. You can get away with just doing half the weights, um, and then all the weights are calculated off of this. So basically, pick a weight for whatever you're doing. In the case that I mainly use, I use 6, 4, and 1, and then I take 6 and I divide it by 16, 4 divided by 16, and then 1 divided by 16, because you always know the sum of each of these lines is going to total to n to some, or 2 to n. So you can calculate that beforehand, and that saves a lot of time once we actually get into our for loop. So the less lines we have to run inside of our for loop, the better. All right, so basically what's going on is first I sample the current pixel. So whatever the current pixel is, I set up texture color outside of the array. So I do that, and then we go in, and basically what's happening is I calculate the UV. I was looking for a way to calculate the UV, like update the UV rather than calculating it completely new each time, but I didn't have enough time to get to that. So we're kind of just left with this. So I calculate the UV, add a offset vector, which is just based off I, and then you do it twice for all the pixels to the right and all the pixels to the left. And one thing to note about this is you don't sample the center because you only sample the center pixel once. That's why it's done out here, and then you start it. You don't ever go over the index 0, because that just wouldn't make sense. You'd just be adding and subtracting the index at 0. So I hope that made sense. So the only difference between this block and this block is the plus and the minus for the different sides. And then the only difference between buffer C and buffer D is I cleaned up buffer D. I left a lot of my experimentation and things inside of buffer C. So buffer D is a lot cleaner. And then it's just modifying the y-axis instead of the x. So hope that's clear, makes sense, and hopefully it's efficient. I'm pretty sure it is. So yeah, I think that's everything.